Right now, Jupiter's Great Red Spot is still tearing itself apart, a storm 3 times wider than our entire planet, and NASA has no way to stop it. It has been spinning for at least 350 years. No off switch, no eye of calm, just endless, screaming wind. And the people who study it at NASA and Caltech will admit something quietly. They don't actually know why it's still alive, but here's what nobody is telling you. What the storm started doing in the last decade is the part they're afraid to say out loud. Let's start with what this thing actually is. The Great Red Spot is a hurricane, but calling it a hurricane is almost an insult. On Earth, a hurricane dies in days. It hits land, runs out of warm water, and collapses. This one has been raging since before the telescope was common. Winds inside it move over 400 miles per hour. It is so wide that you could drop the entire Earth into it and lose us completely. No coastline to break it, no cold ocean to starve it, just a planet of gas spinning a single storm for centuries. And for a long time, scientists assumed it would simply go on forever, unchanged, a permanent scar on a giant world. They were wrong, because the Great Red Spot is shrinking, and it's shrinking fast. When astronomers measured it in the late 1800s, the storm stretched roughly 25,000 miles across. Today, it's barely 10,000. In a single human lifetime, a storm older than the United States has lost more than half its width. And as it shrinks, it's changing shape. It used to be a long oval. Now it's curling toward a circle, growing taller as it gets narrower, like something being squeezed in a fist. The math says a storm this big should be stable. It isn't. It's transforming in real time, faster than any model predicted, and faster every year we look. So the obvious answer is simple: it's dying. The storm is finally winding down after 3 centuries, and we're just lucky enough to watch the end. That's the clean story. The problem is it doesn't fit the data, because as the spot shrinks, it isn't weakening. It's getting more intense. The winds at its edge are speeding up, not slowing down. A dying storm loses power. This one is losing size while gaining fury. The smartest atmospheric scientists at NASA's Jet Propulsion Lab have models for storms. None of them cleanly explain a hurricane that gets smaller and angrier at the same time. They can describe it. They can't tell you why. And this is where it gets unsettling. Remember what I said the storm started doing in the last decade, the part they don't like to say plainly. In recent years, the Hubble Space Telescope caught the Great Red Spot doing something no one ordered it to do. It started oscillating, wobbling. The entire storm, a thing larger than Earth, was speeding up and slowing down on a cycle, like it was breathing. Then it began throwing off long red streamers, flakes of itself peeling away into the clouds, as if the storm were shedding skin. And just when researchers expected the wobble to signal collapse, the color deepened. The red got richer, darker, angrier. We still don't fully know what makes it red. The leading guess is exotic chemistry, sunlight cooking unknown compounds dredged up from below. But the storm chose this moment, while shrinking, while wobbling, while bleeding fragments into the atmosphere, to glow brighter than it has in years. Something is feeding it from below, from a place our probes cannot reach. Jupiter has no solid surface. The storm's roots may plunge hundreds of miles down into crushing dark, and whatever is down there pumping energy upward, we have never seen it and we cannot measure it. Here's the strange part, the part that shouldn't be possible at all. The Juno spacecraft discovered the Great Red Spot doesn't just sit on the surface. Its roots reach at least 200 miles deep, maybe far deeper, anchored into a layer of the planet we know almost nothing about. This storm isn't weather. It's connected to the machinery of an entire world. So think about what that means. We have a storm older than modern science, powered by an engine we can't see, shrinking and intensifying in ways our physics can't cleanly predict, on a planet whose gravity quietly protects Earth from comets and asteroids. If we can't model one storm on one neighbor, how confident should we really be about the giant worlds we're now finding around other stars? Every assumption about how planets behave rests on understanding the ones next door. And the most studied storm in the solar system just told us we don't understand it at all. It's changing while you read this, faster than the experts expected. towards something none of them have named. So here's the question they can't answer and maybe don't want to. When a storm this old finally finishes whatever it's becoming, is it dying in front of us, or is it just getting started? What do you think is really down there feeding it? Tell me below.